Hello, and welcome to iOS 115, Customizing Table Views. This is the second class of a 3-class series on UI Table View in iOS. This course will show you how to customize the appearance of your table views. First, we'll explore how we can modify the default cell styles that are provided by iOS, and then we'll create fully customized table view cells, both programmatically and using the designer. And finally, for larger dataset collections, you might want to enable grouping to help visually organize your data and make it easier for users to navigate the table view. By the end of class, you'll be able to fully customize the way your data appears within a table view in iOS. Let's start with customizing a UI table view cell programmatically. But before we start coding, let's explore the composition of a table view cell. And then we'll look at two different options we have to customize the appearance of our cells. At first glance, a table view cell appears to be pretty simple. For default cell styles, we have the two main content areas, the content view, which will show one or two UI labels to display text content, and for the styles that support displaying images, it can show a UI image view positioned on the left side of the cell. There's also the accessory view. This is a UI view that displays supplemental content. It can show check marks, chevrons, or even, a separate info button, which is typically used to show a pop-up with further details for the data in the cell. The views displayed within the content view are just regular UI labels and a UI image view, and they have the same properties as any UI view you might add to your UI. We can customize the default cell styles programmatically by changing these properties. We'll do this from within the getCell method in the TableView source. Fortunately, Apple has used consistent child view property names for all the default styles, making it easy to know how to reach each child. So for example, every default style has a UI label property named text label. For cells that support 2 rows of text, we can access the detail text label property, and the UI image view can be accessed using image view property. Remember, these properties will be null for styles that don't support that particular visualization. We already learned in IOS115 that we can use the accessory property on a TableView cell to set it to one of its 4 defaults, a check mark, a detail button, a disclosure button, or the detail disclosure button. But we can also use accessory view property to display any UI view in the accessory location, and typically this would be a UI image view. It may be tempting to use the accessory view to display additional image within your cell, but if you need to show additional content, you should move to a fully custom cell. We're going to do that in a little bit. In this first exercise, you'll customize a default table cell. Pause the video, finish the exercise, and come back when you're done. As we saw, iOS provides us with 4 built-in cell styles, which are often useful, and I recommend you use them when they're a good fit for your data. However, they're not always a good fit. Sometimes we want to be able to display more information within a cell, or we want to create more complex visualizations or different arrangements. And in these situations, you're going to create a custom TableView cell. When creating custom cells, we have 2 options. First, we can create a custom cell programmatically. This will require that we create a UI TableView cell derived class and write code to create and position all of the child visual elements within that cell. Or we can use the Xamarin iOS Designer to create and arrange our custom cell. Here's an example of a custom cell. Notice that we have one image and three labels, and our image is in the center. This doesn't match any of our other cell styles. You can think of a custom cell as a blank canvas. You don't have access to the default labels and image view any longer. You'll be responsible for creating and sizing and positioning all of the child views within your custom cell. You can still use the accessory view in a custom cell, but it's not required. And if you don't, you can use that space for your own child views. Let's first look at creating a cell programmatically. There are three things that we need to do. Create a new class for the custom cell. Within your new class, write the code to create, size, and position the child views that visualize your data. And provide a way to populate the child views with the right data for that specific row in your table view. So first, we create a new class that derives from the base UI TableView cell class. When creating the constructor for your cell, you need to accept an int pointer as a parameter and then pass it to the base constructor. This is required when displaying your cell within a table view that has been defined on the storyboard. If you're creating all of your UI programmatically, then this isn't necessary. Within the custom table view cell, you'll create your UI things and add them to the content view provided by UI table view cell class. To size and position your views, override the layout subviews method. Call the base implementation and then position your views, either by setting a frame property or by using constraints. We'll register our cell by calling the register class for cell reuse method on that containing table view. By doing this, we will always get an instantiated cell when we use DQ reusable cell. Remember, this is for our cell reuse. When we're instantiating and populating our cells in the getCell method of our TableView source class. Make sure to use the same cell ID with both methods. And then finally, we need a way to pass the appropriate data for each individual row or cell in our table view. There's a lot of ways to accomplish this, but best practice is to create a public method that can be called by the TableView source to pass in the appropriate data. And then we simply call our update cell method from within the getCell method of our TableView controller, making sure to pass in the correct data based on the index path. And again, remember to use the same cell ID that you used when registering the cell. Otherwise, DQ reusable cell will return null. In this exercise, you'll create a custom TableView cell in code. Pause the video, and when you're finished, come back and continue on. Now that we've learned how to create custom cells programmatically, let's see how we can accomplish this same task using the Xamarin iOS Designer. We'll start by reviewing the Xamarin iOS Designer. Then we're going to look at two different types of TableView cells. And finally, we'll see how to visually create our cells and connect them to our backing data. The Xamarin iOS Designer gives you the same flexibility to create custom cells with the added benefit of visualizing your custom UI without the need to run the app. When you add a UI table view to a storyboard, it will include a TableView cell that you can customize. You can work either with the default cell styles or create a completely custom cell, which you'll design by dragging and arranging child views in your cell. You'll use the Properties pane to control the properties of both the TableView cell and its child views. In the Identity section, you can set the class and name fields. For the TableView cell, you'll assign a class name to create a backing class. And don't forget to provide names for any child views that you'll need to dynamically update from your code behind. When working with cells in the designer, we categorize them into two types. Static cells are used to present static content and will very often have different content, different styles, and different layout for each cell within the table. Dynamic cells are what we've been working with up to this point. Now we're going to look at designing cells when we want to display collections of data. For this, we create dynamic prototype cells, and these behave much like the custom cells we created programmatically. Generally speaking, you'll only create one dynamic prototype cell, but you can create more. You'll just need to write some additional logic to decide which cell type to display given some condition in your data in your code behind. We're going to need to create a custom backing class when working with dynamic prototype cells. This will allow us to access and update the child views to display the correct data for a given row. Setting the identifier field is crucial when using dynamic prototype cells. This is the same as the reuse identifier that you used programmatically when you created custom cells. However, when you're using the designer, your cell is automatically registered. So if you don't set the identifier, you won't get valid cells in the getCell method of your table source. Let's have a small flash quiz. Cells which contain predefined data are referred to as static cells. When creating custom cells, the designer can do everything custom code can. No, the designer is very powerful for creating cells, but if you have to make runtime UI changes in the cell, you'll need to create a custom cell programmatically or modify the cell using the code behind. In iOS 11, TableView rows default to self-sizing rows. If the row content is defined using auto layout, the system can automatically determine how much space is required. If you'd like to opt out of automatic row sizing, you simply set the estimated row height property to 0. If you do that, you must now manually set the row height. In this exercise, you'll create a prototype TableView cell using the designer. Pause the video, come back when you're finished. Static cells are used when you have predefined data or you know the shape of the data ahead of time. A table view will typically use several different static cells, and the design of each cell is set at design time. The UI table view will need to be specifically set to use static cells. You very likely will have less than a couple of dozen cells when using static content. Because of this and the fact that each cell is different, cell recycling isn't used. You can create static cells based off of the default cell styles or create custom cells. And you can use both approaches within the same table. Although it is possible to create static cells programmatically, it's typically done using the designer. To update the contents of the static cell at runtime, maybe you need to load and display saved settings. You'll need to name the cells in the designer and then access the child views in the view controller's code behind. In this exercise, you'll create static cells in the designer. Pause the video, complete the exercise, and come back when you're finished. It's reasonable to imagine a situation where you might want to add several static cells and then continue to populate your table with dynamic prototype cells. However, this is not possible. A workaround, though, is to simulate static cells with dynamic cells that have static content. To use dynamic cells like static cells is as simple as not updating the contents of the cell in the getCell method for a particular reuse ID. If you're using multiple prototype cells, regardless of the content, you'll need some logic to determine which row presents which type of cell. Now let's look at some additional features we can use when our data is separated into logical groupings. We'll start by changing the visual appearance of the table view to show groups. Then we'll add an index for quicker navigation, and finally we'll see how to add headers and footers for each section. The table view has been designed to display data organized into logical groups and includes several useful features to help visualize the separation between each section. This includes adding white space between the sections. And if your data is organized and structured into groups, an index can be used to quickly jump to a specific group. You can change the appearance of a table view by setting the style property. The two possible values are plain and grouped. Plain table views are more compact and the headers and footers stick to the edges of the screen. Grouped table views add white space between the sections to create a separated feeling. You can set a table view's style in either code or the designer. The style must be decided when the table view is created and cannot be changed after it's been instantiated. Remember, this is a visual setting. A style of grouped isn't required for displaying grouped data, but it does make it easier for the user to see the separation between the groups when the application is running. To use groups in our table view, we'll need to structure and sort our data into logical sections. Alphabetically is the most common, but the data can be organized any way you like. Maybe by date, by region, by color, or any other property that is exposed in your model objects. The data will need to be grouped in your code behind. The table view will not sort and group the data for you. This is commonly done using a dictionary or an I grouping, but neither is required by the UI table view to enable sections. To utilize sections with dynamic prototype cells, you must override number of sections in your table source and return the total number of unique sections as an int. This could be obtained from your dictionary or your I grouping. You'll also need to update rows in section method to return the number of rows for each section rather than the entire data count. Here's an example of using a dictionary with the number of sections method. We can simply return the number of keys used in the GroupFruit dictionary. And similarly, we find the number of items in each group. Again, this is just one example of how you might structure your data. You'll see an alternate approach in the next exercise. With our data sorted and grouped, we use an index to quickly navigate between sections. This is a very useful feature when you have a larger collection of data, and it will save your users from needing to repeatedly swipe or scroll through your content. To use the index, 3 method overrides are required. We've already talked about number of sections and rows in section. The final method is section index titles. This method returns an array of strings that will populate the index. You'll return 1 string for each section. Although iOS doesn't place any limits on the length of the index titles, best practice is to limit it to 1 or 2 characters. It's most common to use an index when your data is sorted alphabetically, and an index can be used on either TableView style, plain or grouped, but the data itself must be structured to work with the index. And again, here's an example implementation of section index titles. In this case, we're assuming the fruit is sorted by the first letter and the key is a single character string. Let's have a flash quiz. An index can be used with which type of table view? Both. You must set the table view style to grouped if number of sections returns a value greater than 1. This is false. The table view style is just a visual style. It doesn't have anything to do with whether or not the data is grouped. Headers and/or footers can be displayed above and below the sections respectively. Depending on the style of the table view, the behavior of the headers and the footers change. If the table view style is plain, the headers and the footers stick to the top and the bottom of the screen and aren't removed until a new section is entirely on the screen. If the table view style is set to grouped, the headers and footers scroll with the table contents. And the white space, which is usually gray, is maintained, making it easier to see the division between the groups. Generally, it's not recommended to use both headers and footers if the style is set to plain. To display simple text cells for the header, override title for header. If more control is needed, a custom view can be provided by overriding getView for header. These two methods are mutually exclusive. Use one or the other. The same is true for footer. The title for header method returns a string to be displayed as a header for each section. And again, if you want a fully customized header, you can create a custom UI view to be displayed. You'll be responsible for creating and positioning and populating the child views. Notice this does not return a UI table view cell. In this exercise, you'll create a grouped table with an index. Pause the video and come back when you're finished. Thank you for attending iOS 115, Customizing Table Views in iOS.